FRG has done years of research in resonance systems. This has led to the development of technologies with applications in sustainable energy, lightning protection, freeform fabrication, tribology, and thermoacoustics. Thermoacoustics is the science of generating and amplifying sound waves with heat. Sound waves are simply high-frequency pressure fluctuations in a gas. We use these amplified pressure oscillations to drive a generator. At 10 to 100 atmospheres of pressure, these waves have tremendous power, just like a large pneumatic motor. Waste heat is everywhere. 70% of the fuel energy in a combustion engine goes out the exhaust system and does no work. The same is true of most industrial processes. Solar and geothermal heat constitute limitless energy resources if the conversion equipment is made cost-effective. For example, the thermoacoustic generator we've developed can convert any heat source into cheap electrical energy. This is an electrical outlet common to homes and offices throughout the world. In the United States, it delivers 60 cycle, 120 volt AC current. This instrument is called an oscilloscope. It is used to analyze electrical equipment. This is what 60 cycle house current looks like on an oscilloscope. This is a TAC generator. It has a combustion chamber for operation with gaseous fuel. The combustion chamber can be removed so that the generator can be mounted on a solar collector or in an exhaust manifold for heat recovery. Here the engine is mounted on a stand for ease of tabletop demonstrations. This is a combination waveguide and heat exchanger. Heat enters the engine through the wall of the waveguide and heats the high-pressure gas inside. Sound waves traveling through the gas are amplified. This is how the heat is converted to work. This pressure transducer is a piezoelectric generator. It converts pressure pulses into electrical current so they can be measured on the oscilloscope. In a working engine, it's replaced by a high-output electromagnetic generator. The only moving part in these generators is the armature, making them ultra-reliable. Sound waves simply cause the armature to vibrate within a magnetic field and produce electricity. A technical demonstration follows. We're pressurizing the engine to 4 atmospheres, about 60 psi. In a working generator, the pressure would be about 500 psi or greater. The higher the pressure, the greater the power output for a given generator size. This hot air gun will demonstrate how heat is converted into electrical current. To demonstrate the versatility of this engine, we will do the same thing with an open flame. This time with a cup of hot liquid. Agitation helps transfer the heat. Even body heat will work. Here it's getting heat from the warmth of the human hand and converting it into power. This opens up dozens of biomedical applications. The engine can be configured for solar power simply by attaching a solar collector. Here the generator is converting free solar fuel into electrical power. The MEMSTAR is a miniature thermoacoustic generator about the size of a computer chip. It can be mass-produced in large arrays to harvest solar energy very cheaply. These generators have only one moving part. They're simple to make. The armature for the MEMSTAR can be made of high-temperature plastic by injection molding. The tack armature is metal alloy. In terms of production and life cycle costs, these generators can compete with any existing technology. Here are just a few potential markets. Utility scale solar power. Independent power systems could generate as much as 100 million in sales. Communications satellites and space power systems. Energy recovery from waste heat is estimated at 6 billion. Clean hydrogen fuel from seawater. The tar can make it for 50 cents a pound. That's the equivalent of $1.25 gallon gasoline. It could replace gasoline in most automobiles. Fresh water from seawater to meet the needs of growing cities. The transportation and shipping industries can save millions in operating costs by harvesting the waste energy in engine exhaust and using it to drive electrical and refrigeration systems on their carriers. Some of the global trends driving the market are tough environmental policies, efforts by industry to economize through improvements in efficiency, population growth, and increasing industrialization. Thank you for your attention.